Hello everyone, this is another problem from uniform circular motion. In this problem it said that a man has a mass 50 kg, rides a carnival Ferris wheel at radius 15 meter, completing 5 turns about its horizontal axis by every minute. So this is actually that Ferris wheel which that man ride, and this makes a 5 turns in every minute, and as the radius is r, actually that 15 meter. Now we have to find out what is the period of this motion. In the second question we have to find out the magnitude and direction of the centripetal acceleration on the man at the highest at that point and also at that lowest point over here. And the third one, we have to find out the force exerted by the seat on the man at the highest and the lowest point. Fine. So let's start to solve this one. What are we going to do? We're going to write, say that the radius of this Ferris wheel is given, which is actually 15 meter, and it makes that 5 turn in every minute. So that's mean it makes that 5 turns in every minute, right? Now we have to find out the time period, which is actually that how much time it will take to make a 1 turn. So that's mean we can find out how much a 5 turn it makes a 60 seconds. So how many time it will take for 1 turn. So we should write that 60 divided by 5 seconds, right? So that means it will give you that 12 seconds. That's mean so it time period would be that 12 seconds, because it in 60 seconds it makes that 5 turn. In 1 turn, in that case, will take the 12 seconds. So that is would be the time period of this motion. This is the answer number A. Now for the B, we have to find out that centripetal acceleration on that person. So centripetal acceleration we can find out A would be v square over r, right? And that acceleration we can find out when the person is at the top, it would be towards that direction. That's mean towards the downward. When the person actually at that bottom, then the centripetal acceleration would be towards that center. That's mean it would be the upward, right? We find out the direction in that way. Now what about the magnitude? To find out the magnitude, we are going to use that formula. A would be v square over r. Now r is given, that is actually find out which is bigger r over here is a 15 meter. We can use the bigger r instead of small r, which is the radius basically. Now what about the v? So v, we can find out that v, because we know that the time period, how much time it will take for 1 revolution, then it should be twice by r divided by t, right? We use that formula, v equal to omega r, and omega actually that twice pi divided by t rad per second into r, right? That's how we can find out that v. Now what would be that? We know that everyone, so v is, we can write 2 into 3.14 into 15 divided by 12. That will give me v would be 7.85 meter per second. So this would be that v. So that centripetal acceleration, A would be v square over r, which is 7.85 square divided by 15. So if you solve, then you will find out that magnitude of this centripetal acceleration would be 4.10 meter per second square. So this is actually the magnitude at the top and the bottom. It would be that same magnitude of this one. So that means at the top it would be the direction of the upward, sorry, it would be the downward at highest point, which is mean actually that top point, right? This is actually the top, actually the highest, at highest point acceleration is 4.10 meter per second square, and direction is downward, and at lowest point, that means bottom, and that lowest point acceleration is 4.10 meter per second square upward. It should be upward. So this is actually answer number, question number B. Now in the C, we have to find out that the force exerted by the seat on the man at the highest and the lowest point. To find out that force, normal force actually basically by this seat, we have to draw that free body diagram. So for that once I'm going to redraw this case. Say this is the case, this is the Ferris wheel. So this is the person at that lowest point, it's over here, and this is actually say that at the top point of that person. So if you draw that forces on that person, which is mg, this is actually that normal force provided by the seat, the bottom, and the top, this is the same mg, and this is the normal force on that person, right? This is the case actually. Now we have to find out this in. We can find out for this Ferris wheel at, say that, first I'll write down at lowest point or the bottom, the lowest point. In the case we can write, say that net force must be equal to MAC, right? So what is that force? N minus mg must be equal to mv square over r, where r is the radius. Now we can find out this N would be mg plus mv square over r. Now we can rearrange these equations. I'm going to factor out this mg. This will be 1 plus v square over gr. So this is will be the normal force. Now I know the everything, right? I'm going to plug in. If I plug in that one, so m is 50 kg, so g is 9.8, 1 plus v is 7.8 square divided by 9.8 into r is 15, right? So if we plug in that one, then find out the normal force at the bottom point would be 695.4 Newton. So this is actually that normal force at that person, which is higher than of person actual weight. So that means at the bottom point it will feel heavier. Now at the highest point or the top point, highest point or at the top point, you can write, so this F net must be equal to MAC, and this AC basically would be downward direction, right? So if we choose, so this is my positive X direction and this is my positive Y direction. At the lowest point, the centripetal acceleration towards that direction, which is towards the positive y direction, but at the top point the centripetal acceleration is basically that downward direction towards the center, right? That's why it should be that minus. So I'll write in that case it should be n minus mg must be equal to minus mv square over r, because centripetal acceleration actually v square over r. Then we can find this n would be mg minus mv square over r, or we can find out this mg would be 1 minus v square over gr, right? Now I can find out that this normal force at that highest point, plugging that value, because this is 59.8, 1 minus 7.8 square divided by 9.8 into 15, right? So if you solve, then this normal force would be 284.59 Newton, which is actually that lower than at that bottom point. So that should be basically this normal force, and this one is also actually that apparent weight, because it's the person actual or true weight is basically it is 15 to 9.8, which is 490, and this normal force at that highest point actually the less than that one, top point, which is actually the lowest than of that true weight, or less than the true weight of this person. Okay, thank you very much.